Hey guys, Mr. T here, another video for you. This one on displaying numerical data, but this time continuous numerical data. So when we're dealing with continuous numerical data, we've already talked about how continuous numerical data is usually measured. The problem with that is it can take any value within a certain range. So because that data can take so many different values, it would be ridiculous to make a graph for every single possible value like we have with discrete numerical data. So just to give you an example of what a ridiculous graph like that might look like, if we were graphing the heights of people, which is a continuous numerical variable, the heights, and we were doing it in a discrete numerical style, we would be graphing sort of like every single possible number between particular heights. So it's going to be very rare for you to have someone who's exactly 160 centimeters, exactly 160.1 centimeters, exactly 160.7. But if you were to graph it like that, that's what your graph would look like. There's hardly any information there. You just got frequencies of 1. Why? Because it's really rare for someone to be exactly very specific height. Okay, so there's no real information that you can get from this. You can't talk about shape or skewness or anything because you just got these tiny points. Really sparse graph. So instead, for continuous numerical data, it's preferable that we graph the groups of the data into class intervals which have an equal width. So as an example of that, instead of us graphing every single centimeter, okay, or the difference, a tenth of a centimeter, what you could do is, what if we measured everyone between 160 and 165, say? So make class intervals of 5 centimeters. These would all fit into it. So there'd be a frequency of 4 heights between 160 and 165 centimeters. That might be a more appropriate looking graph that we could talk about the shape of, yeah? So that's an example of using class intervals. We're going to run through a proper one here. And the point of the class intervals is that you would be counting the frequency of data that fall into those intervals instead of frequency of a very specific data value. So what we got here is an example: length of 20 lobsters from a tank measured in centimeters. So we've got all the data here. So let's divide the data into suitable class intervals and display in a tally frequency table. So you usually want between 5 and 10 class intervals. Okay, so how could we divide this into 5 to 10? Well, your lowest value here is 3. Highest value is going to be looks like 7.3. So if you went from 3 to 4, 4 to 5, 5 to 6, 6 to 7, you'd have around 5 there. So what you can do is divide it into class intervals of 3 to length to less than 4. Okay, what does that mean? It's you're interested in links between 3 and 4, but it doesn't include 4. So everything from 3 upwards to less than 4. Why? Because 4 is going to be included in the next one. So this sign here is less than or equal to. So we're interested in numbers that are equal to 3, but less than 4 here. And then 4 is included in this next interval, length, less than 5. So 5 is not included in this next interval. 5 is included in the third class interval, length less than 6, 6 less than or equal to 7, 7 less than or equal to 8. So there's our 5 class intervals. Now we can tally them up. So 4.9 is between 4 and 5. 5.6 is between 5 and 6. 7.2 is between 7 and 8. 6.7 is between 6 and 7. 3.1 is between 3 and 4. 4.6, 6. That's exactly 6 here, so that would be included in this class interval, because that's inclusive of 6. 5 is exactly 5, so that would be on this class interval. 3.7, 7.3 here, 6 exactly there. 5.4, 4.2, 6.6, 4.7, 5.8, 4.4, 3.6, 4.2, and 5.4. Right, so our frequency is 3, 6, 5, 4, 2. Add them up. 10, 15, 16, 17, 18, 19, 20. You got a total of 20 there. Okay, so we've done that frequency histogram for the tally frequency table there. Now draw a frequency histogram. So this is a new thing that I teach you, because you wouldn't have ever heard of a frequency histogram. You may have heard it. Frequency histogram is just a column graph for continuous numerical variables. No gaps between between bars indicates the continuous nature of the class intervals. So what it is it's like a column graph, but there's no gaps between the bars, and that's reflective of the fact that we have class intervals. So we're talking about all numbers between 3 and 4. All numbers between 4 and 5. We're not saying it's exactly 4.2 and have a separate bar for 4.2, separate bar for 4.3. We have a bar that goes from between 4 and 5 and doesn't have a gap to the next one because we're representing all numbers between 4 and 5. So as an example here, this is a frequency histogram of that data above. This is the lengths in centimeters, and so the lowest, we won't go from the lowest, we'll go 0, 1, 2, 3, 4, 5, 6, 7, 8. Alright, so that's reflective of our class intervals. This is frequency. I'm going to draw little lines across to help guide me. Not even, obviously. So 1, 2, 3, 4, 5, 6, 7. Alright, so the frequency histogram is going to look like this. The first length class interval we have is between 3 and 4, and the frequency of that was 3. So your histogram would have a bar that goes between 3 and 4, because we don't know exactly what measurements are represented here. We just know that there was 3 measurements between 3 centimeters and 4 centimeters that occurred. And that's why this bar goes between 3 and 4. Measurements between 4 and 5 happened 6 times. So you'd have a bar that goes between 4 and 5, and that reaches up to a frequency of 6. See how there's no gap? That's because it's a frequency histogram. It reflects the continuous nature of the class intervals, and these are your class intervals here. This is the 3 less than or equal to the length less than 4. This one is the 4 less than or equal to the length less than 5, etc. So 5 to 6 happened 5 times. So that's there. 6 to 7 happened 4 times, so that is here. And 7 to 8 happened twice, so that is there. So that's a frequency histogram. What makes it special? There's no gaps. Why? Because it is a chart for continuous numerical data, not specific data values. So that is A, and B has just been done to draw a frequency histogram. C, what is the modal class? Well, if you look, you can see it on the histogram here, which is the class that occurred most often, between 4 and 5. So modal class is 4 less than or equal to length less than 5 centimeters. Last question. D, describe the distribution, so we're talking shape here. So if I was to draw a line through this, what do you notice? You have more of a peak, more of the data is on the left hand side, which is the lower end. So it's the opposite of what you might think, that is positively skewed. Why? More data on low end, high end is stretched. Alright, so that's answers to, it's pretty much the example 6 from your book, but I just wanted to do it from scratch here and add a few elements explaining what a frequency histogram is. Hopefully that helps you out, and I'll see you on the next video.